Hello everyone, I want to introduce you to the library of functions, and you need to get to know these functions because you will have a quiz on them in class on Thursday. So let's recall first of all what we mean by functions. A function is a set of ordered pairs where no two pairs have the same x-coordinate. And here are some examples of some functions that we've seen before. This is a set, the first one is a set of ordered pairs, as we can see here. This is another way a function can look. It can look like a graph, but this graph is just some ordered pairs made up of ordered pairs. And this is another function that's just a set of ordered pairs. It's an infinite set because every single location along this solid line, and the arrow goes on forever, is a point. And just to recall some things about these functions, remember that the domain are all the x values. So the domain of this first function are the numbers 5, 6, 7, and 9, because those are the x values. And the range values are all of the y coordinates. So that's why here the range is 3, 4, and 1. Same thing over here with this function. The domain is all of the x values. So there's the domain. And the range values are all of the y values. 1, 2, 3, and 4. And we don't have to repeat a number twice. And what about over here when we're thinking about domain? There's an infinite number of points here. It goes on forever. So the points go forever in this direction. So the domain is from negative infinity, and they go all the way to 2. And the range values, well, how low does this function go? Well, since this arrow of this function goes on forever, the domain is forever in the negative direction. But when does it stop? Right here. When we get to how high? Well, this is the point 0, 3. So from 0 or negative infinity to 3. So now let's look at these library functions, which are special common functions that we see often and that you should be familiar with. The first one is called the square function. So that's the name of it. Square function is its name. You need to know the names. And here's the equation for the square function written in functional notation language. And remember that functional notation language, we have f of x instead of y. So if I want to write this in yx language, the equation for this function is y equals x squared, with the f of x replacing the y. And to find some points then on this function, I can just put in something for x and get out something for y. For instance, if I put in 0 for x, that would mean that I would put 0 in the x spot and see what I get for y, and y would equal 0. Or I could put 1 in for x, for example, and y would equal 1. Or I could put in something like 3, and y would come out to be what 3 squared is, which is 9. Or I could even put in something like 1.5, and y equals 1.5 squared. If we put that in the calculator, we'll get y equals 2.25. So all of these points that I have found here are points that are on this graph somewhere. For instance, there's 0, 0 right there. And there's the point 1, 1. And the point 3, 9 we can't see. It would be way up there somewhere, 3, 9. And this point 1.5, 2.25 is somewhere in between here, 1.5, 2.25. Right here, 1.5, maybe 2.25 there. So that's the square function. We want to be familiar with its name, with its equation, and we also want to know its domain and range. So let's talk about the domain. Remember, the domain are the x values, are how far this goes to the left and to the right, and the domain for this function is negative infinity to positive infinity. And the range of this function, well, if I'm driving along on the y-axis, when do I start seeing this function? Right here when I get to 0. So the range begins at 0, and then as long as I'm driving along the y-axis, I can look left or right and see this function forever because these lines go on forever here. So 0 to infinity, including 0. So let's look at another function in the library of functions. Another one is called the absolute value function. Here is the name. There is the equation. If I write the equation with y's and x's, it's the same as y equals the absolute value of x. And let's find some points on this graph. So let's just put in some points here to -2, and let's see what happens. Well, y equals the absolute value of -1 would be y equal to 1 because the absolute value is always positive. Y equals the absolute value of -1 also equals 1. So there's a point. There's another point. The absolute value of 2 would be 2. The absolute value of -2 would be 2. And that's why we're getting these points here, like 1, 1, 2, 2, -1, -1, -1, +1, sorry, -2, +2. So those are some points that are on this function, and if we look at the domain of this function, it's very much like the square function that we just saw. The domain of this function is from this is from -infinity to positive infinity. So the domain is -infinity to positive infinity, and the range, once again, if I'm driving along the y-axis for this function, when do I start seeing parts of the function? Not till I get right here at 0 and all the way up to infinity. I will continue to see this function because these points go on forever. I could continue to put in x values and get a y value, x value, get a y value on both sides. That's the absolute value function. So we've learned too the square function, the absolute value function. Let's see who's left or who's next. Here's one, the square root function. And look at this equation. This equation has a radical in it, the square root of x. Let's look at some points. We can see some points on the graph. There's an infinite number of points on this graph. Now let's find the ordered pairs that go along with some of these points. Well, if I put in 0, y equals the square root of 0 will give me just 0. If I put in, say, 4 in the x spot, square root of 4 equals 2. I could put 9 in this x spot. Square root of 9 equals 3. And I could put in something like 5. Oh, what's the square root of 5? I don't know. Let's check with our calculator here and see if a calculator will come up and tell us if we want a square root. There's our square root symbol. Square root of 5 equals what'd you tell us? Maybe I have to do 5 square root. Oh, there it is. And we get 2 point, what was it? I missed it. Come back, calculator. Well, it was 2 point something. I'll let that go. I think 2.9 something. So what does that mean? All of these points are somewhere on this graph. Where's that 0, 0 right there? Where's 4, 2 right there? Where's 9, 3? It'd be out here somewhere. 9, 3. Where's this point, 5 point? It'd be right in here somewhere. All of these are points on the graph. And the domain of this function, where does it begin? Right here at 0. and it goes forever in the positive infinity direction. And the range, how low does this go? Again, if I'm traveling along the y-axis, I don't see anything until I get to 0. And believe it or not, this function goes on forever, up and up and up and up and up and up and up, because this will continue to get wider. So it's from 0 to infinity. Okay, what's the next function that we want to get to know? The next one here is called the cube function. And the cube function looks like a little snake going like this. It goes forever. Here's the equation for the cube function. And we could write it in xy form. What kind of points do we get? We put 0 in. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. Negative 2 to the third power is negative 8. And then all of these points are somewhere on this graph. The domain for this one, well, let's see. So if we look at our snake here, he's going to go forever. He's getting wider and wider and wider. So the domain for this function is from negative infinity to positive infinity. And the range of this function, how low does it go? Forever low, negative infinity to positive infinity. Sorry, that range word looks terrible. I can write it a little better. Range. Okay, what else is there? Now we have the reciprocal function. This is an interesting looking function. This function actually has two pieces, a piece over here and a piece over there. And there's the equation. So this is f of x equals, why don't we get rid of that box? So we have f of x, or y, equals y equals 1 over x. And what would some of these points look like if we put in values for x? Well, certainly if I put a 1, y equals 1 over 1 would give me 1. But if I put in 2, y equals 1/2, I'm getting a fraction. 3, I'm putting in, I get 1/3, and so forth. So far, what are we seeing? We're seeing these points here, 1, 1, 1, 2, 1/2, and so forth. 3, 1/3. Those y values are getting smaller and smaller on this side. And the same thing is going to happen on this left side if we put in negative numbers. This is a function we'll talk about more when we get to talking about rational functions later in the semester, but we certainly want to be familiar with this now. The domain of this function is very interesting in that it starts forever this way, all the way to here. So the domain is negative infinity, all the way to 0, but never touching 0. And we'll talk in a minute about why it never touches 0 after we talk about the range. And the range for, and the other part of the domain, I forgot about the other side, is from 0 to positive infinity over here, never touching 0. And now, why does it never touch 0? Because if I tried to put 0 in the x spot in this function, that is undefined. So this function will never have a point where x equals 0. And the range is similar here. The range is from negative infinity